this video, I will be going over basic properties of solids, liquids, and gases. Let's get started. All right, guys, so you probably have a pretty good understanding of the properties of solids, liquids, and gases at this point, but we're just going to go through them. So we're going to start by going through this table. So let's start with gases. All right, guys, so just in general, gas particles, I have kind of an example here, and I will insert a little video about it of just showing you guys gas particles.
Gas molecules, as you can see, they are not tightly packed, they're super loose, so they're able to have quite a bit of movement of the particles.
But gas particles are typically just really far apart. So if I was going to draw a picture of a gas, I'm just going to kind of come over to the side over here. If I was going to draw a picture of the gas, the particles are really spread out. They're not super close together. So if we're talking about density, the density of gases is low. And density is a measure of how tightly packed particles are. So it makes sense that the density of gases is going to be really low because those particles are spread so far apart. And they have an indefinite shape. So gases are going to expand to fill the shape of their container. And then they also have an indefinite volume because, just like I said, gases will expand to fill the shape of their container. So they're going to take the shape of their container and also the volume of their container. And they really don't have, there's not a lot of forces holding them together. In ideal gases, which we're going to talk about when we talk about gas laws in just a few days, in ideal gases, really and truly there are no attractive or repulsive forces between particles. Now, in real life, that's not really true, and they do have some slight attractive and repulsive forces between them, but ideal gases, there should be no forces. All right, and then we have liquids. And if I was going to draw a picture of liquids, all right, my particles still have space between them, but they are spread relatively far out. So I was thinking about so gases fly around all over the place and they do whatever. They're spread out. Gases are crazy. Liquids, your particles are still close together, but they're able to move and flow past one another. So liquids, particles are able to move and flow past one another.
Okay, so this is a representation of a liquid. As you can see, there's a lot more movement that can occur in our liquid. The molecules are able to move past each other, but they still are relatively tightly packed as well.
And then solids is where your particles are super tightly packed together. In my drawing, solids and liquids look the same, but they should be close. Solids should be closer than liquids. Just trying to make sure you can see the individual particles. And I will, again, like I said, insert videos of my little examples. But here's our solid right here. It's super tightly packed.
Okay, guys, so you can see this is a visual aid of what a solid particles would look like. So as you can see, they are super tightly packed, and there's really they really can't move very much. So the solid particles just kind of are tightly packed and they vibrate in place or move in place a little bit.
All right. So density of solids and liquids are both really high, pretty high, because the particles are still tightly packed, especially compared to gases. The density of your solids and your liquids is going to be much higher. In general, the density of your solids should be higher. There's a few exceptions to that, including water, where ice floats. So the density of solid water is actually less than the density of liquid water. Liquids have an indefinite shape. If you think about it, liquids are going to take the shape of the container. So this is my cleaning solution. If I turn it, the shape of my liquid changes. But my solids are going to have a definite shape. So like my pen, it's always going to be this shape. Doesn't change if I turn it or anything like that. Volume, though, of liquids is definite. So the amount of liquid I have in here and the amount of space it takes up, whether it's in here, spilled on the floor, or anywhere, the volume does not change of my liquid. Even though the shape can change, it's still the same amount of liquid that's going to take up the same space. And then same thing with my solid. It has a definite volume. It's always going to take up the same amount of space. Liquids are held together by moderate forces. There's still some pretty strong forces of attraction there. Still takes quite a bit of energy to overcome those forces of attraction. And then solid have extremely strong forces of attraction holding them together. Okay, so now let's go through the phases of matter specifically. So we're going to start with solids. All right, guys, particles in a solid are packed close together and they are in fixed position. So what that means is in your solid molecules, your particles are really close and they are in one position. They don't move, but what they do, like just because they can't move and like switch places with other particles does not mean that they are completely still. Your particles in your solid are going to vibrate in place. Now then, this leads to some of the properties of solids. Because they are so close together, means that they are incompressible. All right, what that means is to be compressible means basically I can squeeze my particles closer together. Now, my solids are really already as close as they can possibly get together, so I can't compress them. I can't squeeze those particles into a smaller space because they're already so close. And then because they can't move, it means they retain their shape and their volume. And it also prevents our solid from flowing. So flowing would be the ability for particles to like move past one another. Solids can't do that. Solids can't flow. Some solids have like a really particular pattern. These are called crystalline solids. So this is like salts, diamonds, anything like that that has like that ordered pattern. While others don't have like that set pattern, and we call them amorphous, plastic and glasses. We're going to talk about these specifically in the next few class periods in a few class periods when we talk about properties of solids. You'll learn all about the difference between crystalline and amorphous and some other types of solids as well. Then we have liquids, and in liquids our particles are still packed really closely together, but they have some ability to move and flow past other particles. So they're still really closely packed, but they can still move. Liquids are still incompressible because they are still super tightly packed. So you still can't squeeze them and get them closer together. But liquids, because their particles are able to like move around a little bit, they take the shape of their container and they have the ability to flow. So if you think about like you can pour a liquid out and that liquid will flow and the particles will like move whenever you are pouring it out. So they do have that. However, they don't have enough freedom for the liquid particles to actually like escape or expand to fill the container. So they still do have pretty strong forces holding those liquid molecules together. Then last but certainly not least, we have gases. Gases have complete freedom of motion and are not held together. So our gas particles fly around like crazy and they're going to keep flying in a straight line. So they either hit the walls of the container or another gas particle, in which case they'll hit that container and then like continue moving afterwards, bump off of it and continue moving. They are constantly flying around to each other and bumping into the other gas particles and the container. There is a large amount of space between the particles, especially compared to their size. Since their particles are so small, the space between them is very large compared to the size of the particles. So basically, the molar volume of gases is going to be much larger than the molar volume of solids and liquids since they're able to spread out so much. Okay, so that's kind of basics of the states of matter. In a few minutes, we're going to summarize all of that into a table where we talk about the properties of solids, liquids, and gases. But what we're going to jump into now is phase changes. So phase changes is where I convert from one phase of matter to another. So like solid to liquid, liquid to gas, gas to solid, all that jazz. All right. Now, our attractive forces between our molecules are fixed. So what that means is like if I have a solid, my IMFs, the forces holding them together is going to stay the same. So if I'm going to change that, I have to change the amount of kinetic energy my particles have. So solids melt and become liquids because the particles get enough kinetic energy to overcome those IMFs. So they melt, they start to get more kinetic energy. As they get more kinetic energy, they're able to overcome those attractive forces and become liquids. Same thing with liquids. The stronger the forces, the higher you need to raise the temperature. So the more kinetic energy your molecules need to have. And then, like gases can be condensed by decreasing the temperature or increasing the pressure. Okay, so for example, solids melt when they're heated because the particles gain enough kinetic energy to overcome those attractive forces. It's like if I have my solid particles and they're vibrating in place, as they heat, they start to move faster and faster until eventually they're able to overcome those forces of attraction, those intermolecular forces, and they're able to start sliding past each other because they have more kinetic energy. Same thing happens with liquids. Liquids are moving, they start moving faster and faster, more kinetic energy as the temperature increases until they become gases and they're able to boil. The stronger the attractive force, the higher you need to raise the temperature. Gases are condensed by either decreasing the temperature, which causes their kinetic energy to decrease, or by increasing the pressure, pushing those gas particles closer together. Closer together they are, the more likely they are to feel those forces of attraction. All right, so let's go through our phase changes. So these are phase changes that require energy. So those are endothermic, into, so they take energy in order to undergo our phase change. So our first one is melting, which would be solid to liquid. So that's like ice melting.
Good morning.
Okay, and then next we have vaporization, which is liquid to gas. So this is like water on the stove, boils and it leaves just water vapor. Sublimation, solid to gas. This is dry ice. If you know dry ice, it's solid, and then when it's in room temperature, it lets off that gaseous CO2. Also, solid air fresheners are an example of sublimation as well. So those are our endothermic changes. Phase changes that release energy are exothermic. Exo, I always think of exits. So decrease in energy is like condensation. So that's where we start with a gas and we end with a liquid. Think about like whenever you have a drink out of the fridge or something and liquid starts to appear on that, that would be condensation. Freezing, liquid to solid, putting water in the freezer and it turning into ice. There you go. And then deposition is gas to solid, like frost on the grass, frost on your windshield in the morning, snowflakes form from water in the clouds, things like that. Okay, so now we are just going to fill out this summary chart. So I want you guys to try to fill it out as best as you possibly can, and then we'll go over it. Okay, so fluidity is the ability for molecules to flow. Solids, none. They don't have any fluidity. The molecules can't float past each other, but liquids and gases both do have fluidity. Density of solids is high. Density is how tightly packed molecules are. So solids have a really high density, while liquids also have a high but lower than solids. Gases would be really low. Expansion is ability of the particles to spread out. Solids and liquids don't have any ability to expand, but gases have high expansion. And then compressibility is ability to squeeze your particles closer together. Solids and liquids can't be compressed, but gases are very highly compressible. Diffusion is ability for like it to kind of pass through and to spread. And so solids and liquids aren't able to diffuse, but gases are. Solids are very ordered, liquids are less ordered, gases are arranged randomly. Solids have a definite volume and a definite shape. Liquids have a definite volume but an indefinite shape, and gases have an indefinite volume and an indefinite shape. Okay guys, let's state some matter.